Today I'll talk about safety stock. This is part of my series of lectures on operations management. So replenishment policies may be either continuous review policy, also known as order point method, or periodic review policy, also known as order period method. So when to order is at the order point when there is continuous review policy and at a particular order time when there is periodic review policy. How much to order is same in both the policies and it is OQ, ordered quantity. So this is the continuous review policy. Here we review the situation continuously and we order when order point is reached. And this first scenario I will discuss is when there is uncertain demand and a certain lead time. So let us assume that demand is normally distributed for each period with mean Di, where I stands for period, and standard deviation is sigma I. Let this correlation Ij is the correlation of demand between period I and j. Then for a lead time L, so there is demand during the lead time and written as DL, which is equal to sum of demand of the periods which are included in the lead time. And the standard deviation during the lead time is equal to square root of the summation of square of standard deviations of each period plus 2 multiplied by summation of correlation factor multiplied by sigma of each periods in pairs. So let us assume that the L periods are independent, so the correlation factor is 0 and demand for each period is same and it is written as D and the standard deviation is also same as written as sigma D. So demand during lead time is demand during a particular period multiplied by number of periods included in lead time. And standard deviation during lead time is equal to square root of lead time multiplied by standard deviation of demand in each period. So order point is equal to demand during lead time plus safety stock. And safety inventory is hence equal to order point minus demand during lead time. So service level is defined as the cumulative density function for demand during lead time less than or equal to order point. It can also be written as CDF of demand during lead time less than or equal to DL plus SS. So if actual demand, this is actual demand, so actual demand is less than the order point, so it is a service level. If it is more than the order point, then we are shortage of inventory. Hence, the target should be that safety stock should be equal to the inverse of cumulative density function at particular service level. Usually it is 95% service level minus demand during lead time or D multiplied by L. If the scenario is of normal distribution, if the demand is normally distributed, then we can use standard normal distribution and the formula for order point then becomes inverse of CDF at a particular service level, which is equal to in terms of standard normal distribution. This is the formula for order point and order quantity is demand at a particular period multiplied by time period for next review, anticipated next review. So this is the situation. So there is a order point here When we reach the order point, which is defined as this entity, we order this much entity, we order this much entity, that is d multiplied by t. So this is ordered quantity. We order this much quantity at this point of time, and it is delivered after a constant lead time. And this height is known as safety stock, and safety stock is defined as this particular term. So this is next scenario of continuous review policy or order point method when both the demand as well as the lead time are uncertain. So they both have mean and standard deviation. So let us say that D is the average demand per period and sigma D is the standard deviation of demand per period. L is the average lead time and sigma L is the standard deviation of lead time. So then for a particular lead time, demand is D multiplied by L and the standard deviation of demand during lead time is given as this term. So the order point becomes this in terms of standard normal distribution when the distribution is normally distributed. So, and this is the order quantity. So this is the formula when there is uncertain lead time. So the standard deviation is of the lead time in both the situations. In our previous scenario, when the lead time was constant, the sigma was of D. Here is the sigma of L, and the sigma of L is defined as this entity. So let us move further. When there is continuous review policy or order point method, what are the advantages of central storage? That is the advantages of demand aggregation. So this is the scenario if there is a particular manufacturer and there are distributors and the storage is at the level of distributors. So it is a distributor storage at various regions. Let us assume that demand is normally distributed for each region I to k with mean di and standard deviation as sigma I. So here I stands for each particular geographical region. Since k regions are independent, so each correlation factor is zero. So demand for each this here is the region. So each region is same and is d and standard deviation is different as sigma I. So the safety stock is equal to when it is normally distributed. This scenario, we can use the cumulative density function of standard normal distribution. And this is inverse of cumulative density function of standard normal distribution. So this is the formula for safety stock. And so this is a safety stock for a particular geographical region. So we add up all the safety stocks, that is, we add up all the safety stock of all the regions. So the SS total or safety stock total is equal to sigma of SS each region. And this is the formula. So sigma, uh, because these entities are constant, so sigma then becomes associated with the summation is associated with the standard deviation of each region. So this is the formula for safety stock when there is storage at the distributor level. So when there is central storage or demand aggregation, so the storage at the level of manufacturer and there are distributors in various geographical regions, but the storage at central level. So let us see how to calculate safety stock for this scenario. So let us assume that demand is normally distributed for each geographical region. I is equal to 1 to k with the mean of di and standard deviation of sigma I. And let this is the correlation of demand between region I and j. So then the demand and variation felt at central level is defined as, so demand at central level is summation of demand of each geographical region, and the standard deviation which is felt at central level is equal to this entity. So if we assume that k regions are independent, then the correlation between them is also zero. So demand for each this I'm sorry, this is again geographical region. So demand for each geographical region is same, n is d, and the standard deviation is also, let us assume that it is same as this. So the formula for demand for this is felt at central storage is d multiplied by k, and standard deviation is square root of k, that is number of geographical regions multiplied by sigma d, which is same for all. So SS total is nothing but this entity. So when we compare, so what is the benefit of aggregation? So benefit of aggregation is that this difference, and this difference is given by this term, and the term which is inside the bracket is proportional to the correlation, and in the previous derivations we assumed that correlation was zero. So this is the benefit of aggregation at the central level. Now let us calculate the expected shortage and surplus, and our replenishment policy is the continuous review policy, that is order point method. So this policy is same which we were discussing. Now we are calculating the expected shortage and surplus. So if this function is probability density function of demand distribution, then expected shortage per cycle is defined as integration of demand from order point to infinity, the difference in these two entities. And this is solved to this. So this is how we calculate the expected value of shortage per cycle. Similarly, this is expected value of surplus per cycle, and this is given as, because in surplus, the demand is less than the order point. So it is the integration from x is equal to 0 to order point, this difference, and this is then further solved to this term. So refill rate, that is FR, is defined as lot size minus expected shortage quantity divided by lot size. So now the scenario, this is the different replenishment policy. This is periodic review policy or order period method. And here I will consider when demand is uncertain. So here we order at a particular time intervals, that is T1, T2, T3, and these are lead times. And the quantity ordered is not same but variable. And the quantity ordered is such that we maintain a target level. This is known as order up to point. So if order period is T, then demand is the sum of demand during the lead time plus the period of review. So it is D multiplied by L plus T. And standard deviation is square root of L plus T multiplied by standard deviation of demand during each period. And the safety stock is given as this. We can use this formula if the distribution is not normal, and we can use this formula if the distribution is normal, that is if the demand is normally distributed. And order up to the point, or OUP, or the target level, is defined as this entity. So this is the order up to point, this term, and and this is the safety stock. So let us see an example using Python language. So these are basic packages which are required for our example. And this is the demand of two items, item A and item B. These are historic demands to calculate the mean and standard deviation and distribution of the demand of item A and item B. So let us first see which is the best distribution of demand of item A and item B. So this is the definition of a function which I have written for fitting a Poisson distribution. Because in item A, I could see that the demand is rare and it is the skewed demand, whereas in item B, it appears to be normally distributed. So let us see using the fitting of the distributions. So this is the definition of function of fitting a Poisson distribution. So for item A, we can see that the Poisson distribution is almost fitting the demand. So item A demand is having a Poisson distribution. So assuming that item A have Poisson distribution with a constant lead time, so mean demand per week is 5 items per week, and the constant lead time is 4 weeks. So demand during lead time is 5 into 4, that is 20 items in 4 weeks. And inverse of CDF function, and here CDF function is of Poisson distribution. So inverse of CDF function with service level 95 is 9 items. So order point is 9 to 4, that is 36 items, and safety stock is 16 items. So this is how we calculate when our demand is having Poisson distribution. This is the function to fit a normal distribution. We will try it for item B. So we can see that item B is actually having a normal distribution of demand. So let us add up to certain complication. So we have a lead time which is also uncertain, and these are the historic lead times to calculate mean and standard deviation. And let us assume that the lead time is also normally distributed. So this is our assumption here. So assume that item B have normal demand distribution with a normal lead time distribution. So mean demand per week is 12.38 items per week. We have calculated by fitting the distribution. And standard deviation is 2.92 items per week. Mean lead time is 3.76 weeks, and standard deviation of lead time is 1.786 weeks. So using the formula which I have described, we calculate the order point as 83 items and safety stock as 37 items, and ordered quantity is the demand multiplied by T, that is the time period. So this is all for today. Thank you very much.